We are creating this video to demonstrate a global proven technology in soil stabilization. We are going to talk about RoadCem technology, which is a company established in 1996 in Moerdijk, the Netherlands. It's a global proven technology for civil engineering. Our product is a cement additive, which is sustainable and environmentally friendly product. It's applied in airport constructions, highways, ports, cargo terminals, industrial zones, and currently represented exclusively by our company Fair Trading Group. As you can see, RoadCem around the globe, we are all continents, all the countries that we have flags here, the technology has been already applied. RoadCem, it's a cement additive for soil stabilization that works with what we call an in situ technique with a unique technical properties. We have a properties of impermeability, flexibility, and stiffness, which combined can bring us a lifetime durability over 20 years after we stabilize the area. Only to give an idea about how this system works, the product works. It's a technology that it's a nanotechnology which formates nanocrystals. Basically, we do a soil cement and RoadCem stabilization, and the principle of this technology is that RoadCem enters the cement particle, hydrating the cement particle almost in the whole depth of the particle, and creating nanocrystals, which forms a kind of spider web under the surface that is treated. Due to these properties, we can offer several advantages against the conventional stabilization system. Here's just to give an idea about the scientific partners which work with our company in the Netherlands. We have companies such as Arcadis, which is one of the largest civil engineering companies in the world, that testing technologies and providing and developing projects to different customers. We have the TU Delft University, which in the civil engineering world, it's known as one of the fifth largest in the world in this field. Our technology has been also attested by UNESCO as a technology that brings social benefits to the population, and you're going to understand later on the reason why UNESCO has issued such certification. Also, renowned European institutes like TNO and universities, etc., and certifications which are available to be disclosed in different countries where the technology has been applied. To give a better idea about the advantage, a technical comparison between our technology and the conventional system, we did an example of a road length extension of 1 kilometer by 7.5 meters. So we are talking about 7,500 square meters. In an area like that, normally it takes about 113 trucks to excavate and remove soil, bring new materials, a lot of trucks involved in this process. In our case, due to the fact that we work with the in situ technique, we need only about 7 trucks and a half. It's necessary to remove the soil and materials, about 1,300 tons of materials to be removed on the conventional. In our case, there is no need of removing any material. There is no need to excavate and remove soil, as I said. We need to bring new materials to the site, like sand, gravel, and any other material that's going to be used into the grade, subgrade, and the stabilization. In our case, we basically work with the own soil from the site where it's going to be stabilized, and then we apply a cement and RoadCem. So it's a cemented bounded material stabilization. Okay, and in this case, this example was done considering 168 tons of cement and RoadCem. Also, diesel consumption, we have savings of close to 6,000 liters. And due to all these, issues here, we come at one of the best solutions that the technology brings is the reduction in construction time. In a conventional system would take about 20 days. In our case, we can do in 3 days this area. Our technology, depending on the distance and of course equipment available, etc., we can basically stabilize between 3 and 5,000 square meters per day. Um, it's a comparison also about the convention and ours. When we do this comparison, we can show the superiority of RoadCem that gets even clearer. In the conventional construction, we need to have deeper excavation, soil removal, more delivery of primary materials, high intensity of transportation, etc. In our case, with the in situ technique, fewer primary materials needs to be, available at the construction site. Reduces the construction time by up to 70%, and there is also a cost reduction involved. We also have the ability to stabilize all types of soils, organics and inorganics. And due to the properties of the technology, we have it's also considered environmentally friendly product. So here you can have a better understanding about the difference. In a conventional construction, we have to do excavation, remove soil, and do the base, sub-base, etc. In our case, we use the own soil from the site and apply a mix of cement and RoadCem, which can vary between 15 and 45 centimeters, depends on the traffic intensity, soil type, the loads that we are expecting in the area to be built. And another advantage is that our technology, we can also reduce the asphalt layer. So it's an interest that in some cases we can reduce in like half of the thickness that normally is applied in the construction due to the properties. Here you can see the dynamic elasticity modulus comparing tests that were done at the TU Delft University with the same loads comparing traditional convention with ours. As I mentioned before, stabilize all types of soils, organic and inorganic. We improve the strength parameters due to the high level of impermeability, increases resistance to fatigue. Our technology support high dynamic forces. Just to give you an idea, the technology has been applied in Mexico since 2000. And it has been widely applied in Mexico because one of the other properties of the technology due to the flexural properties, and there are tests demonstrating that our technology even supports has a better response to high dynamic forces like earthquakes, increases resistance to thermal cracking, and the lifetime of the stabilization. As I mentioned, we can prepare the stabilization thickness and the dosage according to the customer interest, the end user interest. We can customize this for 10 years, 20 years, whatever the scenario is. During the implementation, our material reduced the use of our technology actually reduced the use of raw materials, reduced construction traffic, reduces construction time, and the maintenance as well. Here's examples of projects around the globe, and you see here in Brazil, in Urucu, Amazonas, Petrobras project. This is an area that it's a soil, it's a clay soil type, which they found during the analysis, the soil analysis, 4 different types of clays. And as you can see, that was when they were about to start the construction and the area that was stabilized. An important issue also when we are talking about secondary roads or areas that we're going to have only heavy traffic like trucks, etc. We can, there's not even the necessity of applying asphalt layer. Petrobras, after they saw the results, they decided not even apply asphalt into this area because the heavy traffic, only trucks driving over this area would not be necessary. The asphalt actually is applied for, of course, improve a little bit the lifetime, but also due to cosmetic wise to when you are building highways, etc., and also to give a better grip into the vehicles that are transiting in high speed. So that's when we recommend to apply an asphalt layer. Another example, a project done in Alberta, Canada. It's a project at Shell, oil rig in Shell, and as you can see, also very difficult, complicated soil type. And also, all this area was stabilized with our technology, and they decided also to, finalize without applying any asphalt layer on top of it. We have also projects in Mexico, as I mentioned. There's Secretaría de Comunicaciones y Transportes in Mexico, which there are letters recommending our technology. In this case, of course, it was applied asphalt because it was in the middle of the city. Another interesting issue about the technology is the impermeability level that our technology brings into the projects, and the UNESCO has done a study that calls our technology like flooding resistant, so flooding proof. That's an example of a road construction done in the state of Tabasco, Mexico, when there is a lot of water coming over the stabilized area. And you can see clearly here when it started the stabilization of our technology and the traditional stabilization area. The traditional stabilization area was washed out completely, and here you see the transition. Our technology stays intact. That's the area stabilized with our technology after flooding, and that's the area without our technology on the same area. That's why one of the reasons why UNESCO did this study and issue a 152 pages study that would be available to disclose to anyone interested to see that. Another GM parking lot. There's only a mistake here. It's actually in Mexico. It's not in US, but General Motors plant in Mexico. Also, the technology is applied in other areas, like in this case in United Kingdom. We did a pre-construction stabilization. In this case, they were building a pretty large, pretty tall buildings. And they realized that with this soil type, every time that they were inserting those concrete slabs here, they had to stop the machine to adjust the machine due to the weight. So what they decided to do, this machine rental cost in UK, it's about 10,000 euros per day. So what they decided to do, we stabilized the whole area, and then they came with the machine and they finalized this process much quicker. And we even got a building award in 2014 for such work. And here you can see after the stabilization and inserting this concrete slab here, you see that there is no cracks, into the stabilized area, even after this perforation and pressure that was applied into the soil. Here another construction in a highway in Mexico. It was a 70 kilometers highway, and we did use the undamaged asphalt that was in the area. The asphalt was recycled and used it as part of our stabilization with cement and RoadCem. In this case, we were able to finalize this construction in 3 months. So we did 70 kilometers in 3 months. And that's the result after stabilization with a smaller asphalt layer thickness. Examples also in airports. We have airports built with our technology in Canada, in Mexico, in Bulgaria, in Ecuador, in Colombia, and Czech Republic as this example. Also due to the fact that we can finalize construction much faster than a conventional system, and there is not too many traffic of trucks and materials going on and off the construction area. The airport can still be open and without having any issues with our constructions on other areas. Other examples of flooding areas in Germany. That's an interesting project that was done between 2004 and 2006. And this picture was taken 2 years after the flooded area, and you see the asphalt is still intact. So it proves that the impermeability and the flexural properties and the stiffness of our stabilization, even though with a lot of water on top of the asphalt does not, have any damage or potholes or whatever into the asphalt. Also, we have done a part of the Panama Canal expansion, and it's a small stretch that was done with our technology, and we're hired to do. And in this case, we offered a lifetime of 100 years. We have about 10 meters water on top of the stabilization area. Also, technology is applied in mining. This is a mine in Ireland, and it's amazing. There is a video that demonstrates that after the stabilization, it was done about 800 meters depth, into the mining. And after the stabilization, they start having heavy machines with 100 tons weight driving over the stabilization area, and a third-party engineering company doing the analysis, and they verify that there's no cracks, no issues with the stabilized area. Also, oil rigs in Canada, another one. Also, industrial park in Czech Republic. We can use in cargo terminals. We can use in Turkey, industrial parks. Also, water park parking lot in Russia. Our technology responds even in areas where we have a huge climate difference, like sometimes it's 30 degrees Celsius positive and minus 40 degrees Celsius, and the technology responds pretty well to even weather and climate difference, and we are positive that here in the US, in areas that have a lot of snow, etc., this technology is gonna work pretty well. There are several tests that are confirming that technology can be applied in such scenarios. Another example, now in South Africa, it's a highway also built with our technology. In Greece, in this case, was an area that there's not too much traffic, and then they decided to finalize, stabilize the area without applying asphalt. And also South Africa. And for further information, I recommend you to please email us at info@fairtradinggroup.com or contact us by phone or by email. I appreciate your time taking a look into this presentation, and I will be pleased to answer any questions that you might have. Thank you so much.